Hey there. So I'm going to share my screen. Yeah. Share my screen. Sharing the audio too. Yes. If there's an audio, right? And I'm going to shift uh, to the POMQM. So this is how it looks like. So I'm using POMQM. So we start with module 3 on the left side. Of course, you can hide that. And then there are all the modules are here. So we need to do the statistics bit. So let's just do it. So click the statistics. You have data analysis, normal distribution, binomial, Poisson, and exponential distribution. So we start with the data analysis. You can have a title. You can just leave that off. Simple data analysis maybe. Then you can start by putting the number of items that you wish to analyze. It could be blank, because you can even just add subsequent data after it. So let's just start with 12 so that we will have like a yearly thing or something like that. Then let it be raw. If it's raw, then you would have to enter individual data. If it's group, then it would be frequencies, right? Frequencies meaning like 15 to 19 years old, how many? 20 to 24 years old, how many? Then it could be a probability distribution. But in this case, you have uh, raw data, all right? Because it is the case with many things, right? Okay, so you can see it. So we start with the value. If you have data in Excel, you can just paste it here. Okay, of course we don't have that. So let's have just random numbers here. So let this be value would be in sales, all right? So it would be the sales in thousands maybe. So by February, okay, so sales, March, April, May, and June it's lumped because it's tuition month. July increased. August still a lot of fun iPhone. Yeah. Then September it's beginning to start moving up again. October, Burr months confirmed. November, and then by December it could be, yeah, good. Now all you need to do is just to click the solve thing there. And okay, so let me explain to you what this means. The data analysis solution is just the, if you remember the days when you would still compute statistics, and this is the way it is. So you'll have the value, the one that we put, and then uh, the x minus the x bar, which is the x bar meaning the mean. So the mean was computed. So in 2011, you don't need to compute that. Then it will just compute, and then is the program squared it. Okay, and then yeah, just go through, and then they computed for the mean, the median, the mode. What is the mode? 1, 2, 3, 2. Okay, population variance, etc. We have the minimum, the maximum, and all that. So also it sorted the data from lowest to highest. Okay, so if you want to see the analysis here, then you would want to look at the yeah, the solutions. Then you have the statistics, and then you can see also the graph. The graph looks like histogram of sorts. Of course, this is not group data, so you'll have the display bar, okay, and then the display line. The display line would be, the line that connects the data points here. Uh, so doesn't look that good. I mean, it's not as good as Excel, but it's something. And what you can do is you can print screen. I have Yeah, I have light shot. Okay, so you can do additional analysis here, something like that. Right. So those are things that you can do. Yeah, of course we don't need that. Another thing that you can do here is the normal distribution. Okay, normal distribution. Uh, you are already given the 1111.167 computed mean, right? The standard deviation was also computed, and then the variance is just the square of the standard deviation. And you are going to um, ask the program to do a table, a compute for the value given probability, and you can put either one-tailed or two-tailed on a 95% probability, okay, so that you will see the normal curve. Now, if you compute that, then it looks like this. So that means that if the mean is 1111.17, then you are 95% sure, or the data, 95% of all the data would be between negative 65. Of course, there's no negative sales. So this is just an analysis based on the mean minus 2 point something standard deviation. So that's the reason for that, because the standard deviation is high. So 600 standard deviation, that is the diversity, the dispersion of the scores. So if you have two times the standard deviation, that's already 1,200. That's the reason why it's negative. Plus, if you multiply this by 2, the standard deviation, you will have 1,200 plus 1, that's about 2,300. So what this means is simply 95% of the time, it will be between this, which is negative, of course, and then positive 2,287. Okay, so you'll see here that 2543 can be considered a fluke because it is above the 95% uh, probability. Let's look at the table. Yeah, yep, okay, close. So if you want to compute again, and then you wanna just look at the 90%. The value is 90%. Okay, 90%. And then if you data compute data entry, 90% table. Sorry about that. Compute. Yeah. So if it's 90%, then you are 90% of the score. So 9 out of 10. The sales would be between 123,6086 and 2098. Again, if you look at this data, the given data that we were given, we can say that December data is simply out. You know, it can be given this, it can be just, you know, uh, uh, chansical. It only happened by chance. It's an accident. It's a fluke. Of course, we only have 12 data points. That means we're not really sure. And look at the standard deviation, very high. So we're not really sure. But just to give you that, 90% of the data lies between these two data. So that's how the normal distribution factors in. Okay. So if you wanna know the usual data, then you can make use of this. Okay, what else can we do? Probability given value. All right. So if this is the mean and the standard deviation, of course, uh, we can compute for the value. Okay. Let's look at the left. Like for example, 900, 900. Sorry. And then right would be 1,350. Okay. Compute. 900, it has to be left of the mean, and then of course this should be right of the mean. So compute, that would be the one. So left of the mean 900, right of the mean is 1,350. What is the probability that the value would lie between 900 and 1,350? The answer is 29% of the time. So if you wanna look at the values here, 900, we have 1 3 50. So 1 January, February, 3, okay, 4. No, this is about 1, 2, 3, 4, 5. That's 5 out of 12. So you can just compare. 5 out of 12 is about 9, 8, about 30 something percent. We have a calculator here. 5 out of 12. What is 5 out of 12? Come on, come up. Oh no, it doesn't come up. So I kept on clicking. 5 divided by 12 equals, yeah, so 41%. 41%. And then what did we compute? We computed, oh no, we computed 29%, I guess. Yeah, that's, yes, so this is the one. We computed 29%. Actually, it's 41%. So yeah, we're not really that close with reality yet, because as I said, we only have 12 data points. Okay, what else can you do here? Yeah, normal distribution. Okay, so let's look at normal distribution now. So we have a new uh, module, which is normal distribution. Uh, okay, compute cutoff. Yeah, we already have that, so we don't need that anymore. Uh, Binomial is the same actually. So that's what we have for this. Yeah. So data analysis, row group data. What if it's a group data? Okay, frequency classes. Let's have this. Okay, if it's a group data, okay, class interval 1. So let's just put 15 to 19 years old. Usually this is the 20 to 24 years old, 25 to 29, and then 30 to 34 years old. Okay, the midpoint or value would be 15 plus 19 divided by 2. So usually 15, 16, 17, 18, 19. So that's the middle point, 17. Okay, so the class interval would be 5. So that is 22, 27, 32. So why do we have that? This is simply, oh sorry, let's remove this already. Okay, let's just put one more. 35 to 39 years old. And plus 5? Plus 5 is 37. Alright. So now we have, can we just, hmm. So the frequency would be how many individuals are in this range. Alright. So like if you have a group data, how many individuals in the range? So let's say about 25, and then 20 to 24, about 30 people, 25 to 29, about 42 people, 30 to 34, 28 people, and then 35 to 39, about 21 people. So let's just say that this is the distribution of your human resource, right? So what is the mean? This is the computation of the mean, but this is a grouped uh, mean. So the population variance is 41, population standard deviation is 6.42. So if you want to look at the normal distribution, and the mean is 26, standard deviation, and you want to be 95% sure, then it looks like this. So it's 95%, 14 years old to 39. Of course, there's no 14 years old in our list. And as I said, this is because of the high normal distribution. If you want to edit data, you want to see 90% of the time, you will see it's between 16 and 37. Again, there's no 16 years old in the list, of course, right? How about 85%? 85% of the time. 85% between 17 and 35 years old. Yeah, so this is how you can look at the data. And if you want to also look at the solutions, the graph, and it looks like this. 15 to 19 years old, 25 people are there. 20 to 24, there are 30 people there. Okay, and also 42 people within 25 to 29 years old, 30 to 34 and 28, and then 35 to 39, 21. Yeah, so that's how to do it. Okay, so I think that's about it for the statistics using the POM, QM. Of course, if you will look at all this aggregate planning, assembly line balancing, there are many, even forecasting. You have a lot of statistics that are here, right? But other than the central tendencies, of course, we have the time series, past periods. We have forecasting here, right? Time series. We have least squares method. Okay, our observation is there. Regression projector. We have I think the time series. Okay, so if we have here, let's say for example that one, you can even choose what kind of method that you have, right? Moving averages, naive method, linear trend. There are many things that are here in this POM QM uh, software that you can make use for your statistical analysis. So that's it for now. Thank you very much. See you next time.